Alright, this video is going to be the first in a new playlist of videos for our Calculus 2 course. And this particular playlist is going to cover three main techniques of integration: integration by parts, trigonometric substitutions, and partial fractions. If you're looking for U substitutions, you can go to the Calculus 1 playlist that's popping up on your screen right now. But let's get on with this problem. This is the first integration by parts problem that we're going to do. And I know that there are a lot of videos out there to explain where this integration by parts formula comes from. My really quick version of that is if we just move this term over to the other side of the equation, and imagine taking a derivative, or maybe more appropriately a differential. The derivatives and the integrals will cancel each other, and we'll be left with this thing right here, which you might recognize as the product rule. So my 15-second explanation of integration by parts is just that this is the integral version of the product rule. Okay, so I'm going to erase this, and let's talk about this problem specifically. When we're integrating by parts, we always need to choose a u from our integral and a dv from our integral. Our u is typically chosen to be something that will simplify when we differentiate it. So if we choose u equals x, you'll notice that if we differentiate, we get du equals dx. Well, when we're integrating by parts, our initial integral should be u times dv. So I guess that means that this dv is going to be everything else in this integrand. If we want to find v from that just requires integrating. And the integral of cosine is positive sine. Then what we do is we take the u and the v and we plug them in right here. We plug our v in here as well. And we take our du and plug it in right here. And we rewrite this integral using that integration by parts formula. Plugging all of the pieces in gives us this. And if we've done this correctly, the integral that remains in this problem should be simpler than the integral that we started with. And in this case it is. The integral of sine of x we can complete. We know that the integral of sine of x is negative cosine of x. That negative is going to cancel with that negative to give us a plus cosine of x. This integral does not have limits, it's indefinite, so we're just going to tack a plus c on the end of that thing, and we are going to call that problem complete. Okay, let's check out the next one.